Okay, hi everyone. So once we have done our descriptive statistics, typically the next thing you want to do is what we call inferential statistics. So this includes basic tests of difference and tests of correlation. So you would have heard before now tests of difference, such as t-tests, when you want to find if two collections of data are significantly different from one another. And also tests of correlation, such as a Pearson's correlation, where we are effectively trying to work out if there is a significant relationship or a significant correlation between two pieces of data. Okay, so I've just got some example data here again on an Excel document. We're going to talk through and demonstrate some of the simple measures we can do on Excel in that sort of context. So let me talk you through this example data. So on the left-hand side, we have two bits of data, and it's age data. So we have one set of individuals on the far left column, which are a set of males or men, and this is all of their ages in years. And the next column is a separate set of individuals, a set of females, and again we have their years, their age in years. Okay, what I've done before now, linked to the first video you would have watched, is calculated the mean and standard deviation for each male and female ages. Okay, so there might be a question where you have this type of data and you want to find out, is there a significant difference in the ages of the male group compared to the female group? Okay, so you would need to do some sort of test of difference to work that out. And in that sort of situation, we would need to do what's called an independent samples t-test. Okay, and we would want to do that because they are, as the name suggests, independent groups of people. One of the groups is made up of men, and the other group is a completely different set of people made up of females. Okay, so that's why it's an independent sample t-test. Okay, so I'll just show you how you can do that on Excel. It follows the same sort of pattern as the descriptive statistics followed. Okay, so you click on the cell in which you want the answer to appear in. You start all of the commands with an equals. Okay, and then you simply type in the word t-test. You open the brackets, and then again Excel tells you the information that it needs in order to run a t-test. Okay, so where it says array 1, array 2, that simply means the data set that you want to include. Okay, so array 1, I'm going to highlight the male ages. I then need a comma. Array 2 is just the female ages. Okay, so now Excel has the data in which it's going to perform the t-test on. It just needs two more bits of information before it can complete the t-test. Okay, so the first one, we need to either enter a number 1 or a number 2. Okay, whether it's going to be a one-tailed or two-tailed distribution. We're going to go with two-tailed distribution. Don't worry too much about that now. Hopefully you would have heard about that in the lecture. So it's going to be a number 2 for two-tailed distribution. Then need another comma. And the last question is the type of t-test you want it to perform. So it's either a paired samples t-test or an independent samples t-test. Okay, and we're going to go for the two sampled, which is an independent sample. So I can either click on this or enter the number 2. Okay, so I now have all the information that Excel needs. I close my brackets and I press enter. Okay, and this value that has appeared here, I'm going to make bold and perhaps turn it into red so I can help it stand out, is the p-value. Okay, so this 0.255 is a p-value for an independent samples t-test, which has been conducted on the age data. Okay, hopefully you are looking at that and saying to yourself, 0.255 is over the threshold value of 0.05 that we use, and therefore we would conclude that there is no significant difference in the ages of the males and the females. Okay. It might be that you want to put this data into a graphical format to visually look at the data. Okay, now when it comes to difference questions such as this, is this group different to that group? We would recommend some sort of bar chart or bar graph. Okay, now you can spend ages and ages working on creating a graph that looks academic and well structured. I'm just going to show you the first part of creating a bar chart in Excel, and then we can develop those further in future sessions. But typically what we want on a bar chart is the mean data for each of the groups that we're working with. So I would simply highlight the two mean values, okay, the mean age of the males, the mean age of the females. I would go along to the correct tab at the top, which I'm just flicking through now. Okay, so insert. Okay, so the tab at the top will be insert. I'll come along here. This is the section where you can choose the different charts that Excel can use. You can hopefully see my cursor there. And I'm going to click on this one here. Okay, if you hover above it, it will come up with a word, and the word here is column. So I'd click on that and click on the first one. And then you can see here, I have a chart or a graph that has the mean of the males on the left-hand bar and the mean of the females on the right-hand bar. Okay, we have the units on the y-axis here. Okay, so this would be age in years, and we have the two different groups on the x-axis. Okay, now you would then spend a bit of time making sure the format and structure of this chart is correct. So that would include things like getting rid of the title on the graph, because we would have a figure title below. You'd probably want to get rid of the grid lines. You would want to label the axes. Okay, so give this a title, i.e. years in age. And then you would also want to add error bars to these columns, which would give you the option of including your standard deviation onto the chart. Okay, so typically we have the columns as the mean and error bars with the standard deviation. Okay, so that is an independent samples t-test. Okay, if we move along to the second set of data here, so this in the middle. So this example data is just some made up data, and the story behind this data is that we've got a group of individuals and we got them to throw 3 darts at a dartboard and then recorded their score. Okay, and this is their score on the first column, so the pre-column. We then gave those same individuals some darts training, some structured darts practice, some expert advice, and got them to throw another 3 darts post that training. And this is the dart score that they got from 3 darts after that training. So what we have here, in essence, is the same individuals performing the same task on 2 different occasions. So we have pre-training dart score and post-training dart score from the same individuals. Okay, so we want to find out, has that training been effective? And the way to answer that question is to again do a simple test of difference on the pre-values versus the post values. Okay, and if there is a significant increase in dart score post-training, you could perhaps draw the conclusion that the dart training was effective. If there was no significant difference pre to post, you might not be able to make such conclusions. So again, we need to do a t-test. However, because these are the same individuals doing it twice, we're going to do what's called a paired samples t-test. Okay, and again, the process is exactly the same. So I'm going to click on this cell because this is where I want the answer to appear. Equals t-test, open brackets, first set of data, comma, second set of data. Again, I want a 2-tailed option, so I enter the number 2. And the only difference this time is I want it to be a paired sample t-test, as I said, because it's the same individuals on 2 occasions. So that's a paired data. So I entered the number 1, close my brackets, and press enter. Okay, so again, this is my p-value. Okay, So 0.004. So again, hopefully you're looking at that and realizing that that is lower than, smaller than 0.05. And therefore we can conclude that there was a significant difference from pre to post on 3 DART score after some DART training. Okay, and if you look at what direction that difference occurred, you can look at the means. Okay, so the post mean was 114 compared to the pre of 90 points. So therefore you can say there's a significant increase in post-training DART score compared to pre. Okay, and again, if I wanted to put that information into a graph, I would use a column chart or a bar graph with the means as the column and the standard deviation as error bars. Okay, last but not least, I'm just going to run you through an example of how to perform a simple test of correlation, okay, or a test of relationship. And what we're going to use here is we're going to use a Pearson's correlation, okay. Now the example data we've got here for you is 2 sets of data. So on the left column here, we have revision hours, okay, and on the right column, we have exam score. Okay, so what we've got here is a set of students, and they had a test coming up, and the students had to record how long they revised for in hours in the lead up to their test, and then we plotted that against their exam score, because the question is the number of hours that a student revised for correlated to or related to their exam score? Okay, so effectively, are those who are revising the most getting the best exam scores? Are those revising the least getting the worst exam scores, and so on and so forth? So that is a relationship question. Okay, so what we would do here, again, I want to click on this cell. I'm going to press equals. I'm going to type in Pearson. Okay, and the lecture material and the information before now will help you understand why we have chosen the tests we're choosing at this point. Okay, so why we're choosing a Pearson's correlation. But for now, we're just going to look at the how to conduct it. So again, first set of data separated by a column, second set of data separated by a comma, sorry, close brackets, enter. Okay, now this is not a p-value. When it comes to a Pearson's correlation, the value that the Excel gives you is the R value, the relationship statistic. Okay, and that gives us some information as to the strength of a relationship and also the direction of a relationship. And again, from your lectures, you should know that a correlation or an R value of 0.97 is a very strong positive correlation, okay, which means as one value increases, the other value also increases. Okay. Now the type of column or chart we would typically present these data on would be a scatter graph. Okay. Now you wouldn't just use the means in this occasion, you would use all of the data. So I'm going to highlight both sets of data. I'm going to go to the Insert tab. I'm going to hover above this bottom one, okay, labeled XY scatter. And I'm just going to click on that first, most simple form, okay? And what we have here, and again, we can spend a bit of time turning this into a more academically formatted figure, but just for demonstration purposes, what we have here is we have one of the data sets along the x-axis, and in this case it's revision hours on the x, and on the y-axis we have the exam score. And we can see as one value goes up, the other also goes up.